Dun, 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 dun. All right. Now that you had to sit through that and watch that, we're gonna get to some pretty high level. It's gonna be I'm not the best person to kind of speak on this. So if you're a junior level engineer like myself, then this is the perfect video for you. Because I had a bunch of questions pertaining to the topic we're about to go over. So maybe some of those higher level questions can kind of introduce you to this concept. So there's not a lot of code, not a lot to understand here. But before we get started, I'm the Kodiak Killer, and this is actually our last video in the LinkedIn Learning challenge set. And if you haven't checked it out and you're into C#.net, go check the challenge out by Harrison Ferrone. It's actually really good. And I also don't want to make this a 20-minute video, just blabbering on. So I am actually going to get straight to the content. All right, this is going to be quick, but it will be worth your while. So stick with this real quick because as you start to get more advanced with C#.net, here I am blabbering again. Just watch the video. It's cool. We're going to get into what's called reflection and C#.net, which basically allows you to, at runtime, see data about your data. Uh, okay, what does that mean? So for the longest time, I struggled to understand what is metadata. But through doing this project here, metadata finally kind of clicked. Like I just said, it's data within data. And in our case, reflection in C#.net lets you basically see, in this particular example, we're able to see the data. So our classes um, and our objects, and we want to see um, data about our classes, such as like properties and methods within and stuff like that. As you're about to see, I'll explain where this stuff is, where reflection is invaluable as you start to get into things like um, working with databases and working with object relational mappers like Entity Framework and working with JSON serialization and deserialization. Now, I don't have a lot of hands-on experience with those things, but I do have a good conceptual understanding, and I can kind of explain a little bit why reflection plays a huge role in your ability to work with JSON, your ability to connect with databases using ORMs. And then another thing, and I'm not well versed because both from a practical and conceptual standpoint when it comes to unit testing, but that's another big thing that reflection benefits. So without further ado, the last and final problem basically um, was a very, very, very simple um, example about the power of reflection. So the video goes. So we need to present options to users in the most efficient way possible. Okay, whatever that means. And we have a to do, which is find all concrete classes that inherit from an abstract class. So here basically is what we're doing is we're getting metadata. So we're getting data about our data. In this case, um, where our abstract class, you can view that as maybe our data. And then the data within that data are the concrete classes that are inheriting from the abstract class. So hence we're getting the metadata and we're using reflection to do that. The function that we're going to create is going to take in a type for the abstract base class. We're going to return a list of types containing but not including. I said I'm assuming the abstract class. Stick with me here. I know this is a little boring, dry, but we'll get to the juicy part here in a second. All concrete classes that inherit from the abstract class. So we just want to return a list of all the base classes. Asked ChatGPT if this was even possible because I had never run into something like this. Yes, it is possible. It said no, um, but then it said you could do it through like a roundabout way with something called reflection. And I had actually encountered reflection for the first time, like I said, in the same day that I started that challenge, which is kind of cool. And reflection is, I think, I could be wrong, but I'm pretty sure it's a fairly advanced topic. Um, yep, I said that basically reflections allow you to get metadata about an application. And my question was, when would the beep bleep would we ever know how to do this? Would we ever need to know how to do this? Well, I later found that out. We'll have to get to that in a second. And then I watched this video, and this guy is a principal uh, software development manager at Microsoft, dev leader, and I'm also about to get a new pair of Vivo Barefoots. Um, if anybody's interested in minimalist footwear, check out Vivo Barefoot. They're they're awesome shoes. So I got my Vivo Barefoot right here. Yes, I do. Right here, it's a little bit dirty, but probably time for a new pair. Regardless, be quiet. Get out of here. Oh, and I just ate Qdoba. So if I go to the bathroom mid video, you'll know why. All right. So we watched that from Dev Leader. Dev Leader has a okay video on that. Then we phoned an expert, and the expert's opinion was that reflection comes in very handy when maybe say you're upgrading to, um, like I said, I'm kind of new to this stuff, so don't butcher me if some of my terminology is off. But say like you're migrating or you're going into a new version of .NET, then reflection is a good way to just kind of understand the inner workings of the application, what new data types have been introduced, things like that. Just anything you need to know about how the application is running, reflection can be used at a very high level. Okay. And then to solve the problem, I was thinking about doing something like this: var new assembly get executing assembly, which is correct. We're going to use that. Now we can use reflection and ask new assembly for all the types. Yes, that's correct. All right, now we get to the juicy parts. All right, go. Um. All right. Like I said, we can use reflection to present the data that's already there in the app, kind of like the data of the data, like stated. All right. So this is what our function entails. So we call it get models here. So this is where we will get all the types in the current assembly. And then question, what is an assembly? So an assembly in .NET comes in two forms. So um, they can be in the form of a DLL, dynamic link library, or an exe executable file. The executable file is a standalone application from what I gathered, and in a DLL, you can kind of use those as class libraries, so they can work with other applications, and you can kind of reference the DLLs within an assembly. Um, so looking if that's confusing, which I'm assuming that is, but I am no expert. Um, Go check out a little bit more about DLLs and executables within .NET. Alright, so we get the current assembly. This allows us to get all the types, value types and reference types, etc. What are value and reference types? So a way that was actually explained really, really good today was that because C# abstracts memory from us, so unless you're comfortable with um, manual memory manipulation with languages like C and C++, then conceptually you can get a pretty good solid understanding in C#, but ultimately you're still kind of um, you're still kind of it's still abstracted in a way. So, um, but ultimately, um, it was explained like you can think of it like value types are things like, of course, you have integers, doubles, decimals. And when you declare, you don't even have to instantiate. Just when you declare a value type, it you allocate a fixed amount of memory space taken up in the stack. So integer is a 32-bit type. So when you declare a new integer, it takes up 32 bits in the story. If you declare a double, 64 bits onto the stack, in the story. A decimal, 128 bits onto the stack, end of story. You cannot modify an int, a double, or a decimal length. It's fixed. So that's kind of value type. It goes beyond that, but you can think of it like just from a standpoint of, and then structs are value types as well. But just from a standpoint of being able to categorize different um, different value types and reference types, just to be able to pinpoint them and say, okay, well, all right, well, classes are um, reference types, or arrays are reference types, or strings are reference types, and then integers are values types, doubles are value types. Just to be able to categorize them, you can think of them that way. Value types are kind of they're static. You can't really manipulate the the length of them, but for reference types, you can think arrays, like I just said, arrays, um, objects. I shouldn't say objects. Arrays, classes, um, strings. We can change the length of those types of things. Um, okay. So, that pause was because, well, strings are immutable, aren't they? So that definition that I was provided earlier, if strings are immutable, then we can't. Then I'm kind of questioning that definition that the guy said earlier, that we can change the length of it. But I guess ultimately you can concatenate and build on strings if you wanted to, even though strings are immutable, which you would create a brand new string. So I guess in that context he's right. Regardless, let's get into the meat and potatoes. Um, Meat and potatoes here, people. All right, so basically, I'm just gonna run through this real quick. It's nothing crazy. So first thing we want to do, we have the namespace system.reflection that we want to use, which allows us to use the assembly-based class. We call the method get executing assembly. We store that into a variable called assembly. Then we get our types. We use the get types method, which just gets all the types available for that particular assembly. And then once we have all the types, then we run a link query that has a lambda in there. Say where here we are using are we using query or method syntax here? I don't know. But regardless, we're filtering where T is a subclass of type car. Back to the original problem. I don't think I ever specified the original problem. So basically, we have a factory, we have an abstract class car, we have sedan, sport, truck, all inheriting from car. Um, so like, I don't know how real that example is, like how practical that example is in the real world. But ultimately, it's just like I feel like this problem is an introduction more than anything into reflection. Um, just to show kind of what's capable almost, because reflection, it seems to be fairly an advanced um, topic. But regardless, we filter. We want to make sure that T, and it already knows that lambda, it already knows what we're filtering on, what type we're filtering on. So it goes type, what goes in types. We have types, and then we just want to make sure that type is a subclass of type car, and then we also want to make sure that it's not abstract, which is exactly what we want. Then we just run a for each loop, and we get our results when I press enter. Okay, we have all of our vehicle types. All right, so just some quick questions that I ran into that you guys might have that might clear some stuff up. Uh, this video is almost over. I tried to make it as short and concise as possible while introducing the main bits of reflection. So reflection allows us to work with types dynamically. In this context, what does dynamically mean? What's the alternative? So dynamically basically means that we can work with reflection um, with types dynamically at runtime. So as the application is running and new plugins um, and new things come in, then we can work with the types that are in our application and modify them in a way that allows us to work with new stuff that comes in. As you'll see what I mean by stuff here in a second. And do that dynamically in runtime. And the alternative would obviously be compile time, which doesn't really make sense to do it in compile time. Reflection allows us to inspect, like I just said, types without knowing them at compile time. So like we do this at compile time, or we inspect types at runtime because we aren't able to know them at runtime. So basically, it doesn't really make sense to do it at compile time because you can't really change anything while your application is compiling into, in this case, intermediate language and then common language runtime. But when your application is in the runtime, that is when it would make more sense to be able to um, kind of get information from your application and uh, get information about the certain types that you have and the metadata so that you can allow to interact with different plugins like stated. Reflection lets us load assemblies at runtime. Does this mean like loading class libraries? Yes. Um, that's a component of it. We can do that. But another component of this is, well, I mean, yes, the answer to that is yes. A component of this is loading class libraries based on different plugins that come in. Okay, what is metadata? We went over that. Um, And I said metadata, think of it basically like reflection is telling you about what the hell, I should have said, what the, come on, Kyle. What the, we need to fix this. What the bleep is inside of your program so that new data and plugins associated with your new data and plugins associated with your app can map to different properties and objects. So in the real world, this is the question we've all been waiting for. When will I use this in the real world? Well, it made really good sense to me when they put reflection in the context of JSON when you're deserializing. Is it you're deserializing or serializing JSON payloads? I always get confused. I think it's you're serializing JSON into objects and deserializing objects back into JSON, or when we're using something like Entity Framework or Dapper or any other ORM object relational mapper to map our objects that we have in our application um, to our columns and our tables and our databases. So ultimately, when we're working with something like an API which has JSON payloads, then well, we're not going to know what that JSON is at compile time. So, but once we get information at runtime, then we ultimately need to know, well, we have this JSON payload which has objects in it, and we need to know about our application and the structure of our application and the types within our application so we can map those objects together and inevitably serialize that JSON in a way that we can work with it in our application with our objects. And then the same applies for working with databases. It just kind of lets you, it gives you information about your application so that it can map to the columns in particular tables in a database, MySQL, Postgres, SQL Server, and they can kind of communicate in that way because reflection tells everything what's going on within your application so things can kind of work together. And then it also works good with unit testing, which I have right here. But I haven't really done that much with unit testing, so I'm not going to speak on it. But that pretty much wraps up. Not a lot of code here. Pretty intuitive with what's going on, but that is reflection at a very high level. I hope I didn't completely butcher it. Um, you know, honestly, I got double beans with Qdoba, so it's honestly it's a miracle that I actually was able to be articulate when talking about reflection because a couple days ago I just had no clue. And on the same token, it's a miracle that I didn't have to use the restroom because double black beans people is no joke. This is like the Qdoba, so this is high quality. These are high quality beans. This is no Taco Bell bean paste on a burrito crunch supreme. You know, we're in the big leagues here. Um, but I can feel it coming on, so I'm gonna end this video while we're rolling. That's it. We reflection. Um, just basically at the end of the day tells us what the heck is going on within our application through metadata, which lets us kind of interact with different plugins that we encounter during runtime. But there's a lot more to it. And the example that we had right here was very simple. And the practicality of this, I don't know if it's very practical or not, but ultimately I think this was Harrison Ferone's way of introducing us to the world of reflection, which is obviously a huge part in .NET. All right, that's it. I'm out of here. You guys take it easy. Peace out.